Thanks for tuning in and welcome back to the shop. This is our 2013 Mitsubishi Fuso FG, and if it doesn't build fuel pressure today, there's really only one thing left that it could be. You see, I've chased the path of fuel all the way to the pumping element of the fuel pump. I've completely removed the fuel injectors from the system, and I know that the pumping element is actually moving up and down as the pump is rotating with the engine turning. We are down to three possibilities of what could be causing this problem. Let's see if we can narrow it down to one. Last time I was working on this, I showed that fuel is getting all the way to the top of the pumping element. That means the pumping element is getting fuel and the pumping element is going up and down. What I don't know is fuel actually getting out of the pump. Inside the top of the pump, we know we have the fuel delivery valve. That's where fuel from the inlet gets delivered to the piston. But there's also a small check valve and a really small passageway on the discharge side of the pump. So in between the pumping element that's inside here and the fuel pipe that runs up to the fuel rail. If there is something blocking this passageway, no fuel will be able to get out of the pump and go to the fuel rail. Now we know we have fuel here at the outlet of the pump, but the problem is that actually comes from the rail. On the 4P10 engine, the electric lift pump actually backfills the rail so you don't have any air in the system if you ever run out of fuel. So just because we have fuel at the outlet of the pump doesn't mean it's actually coming out of the pump. What I'd like to do is come up with a way to confirm that fuel actually comes out of the pump when the engine's cranking over. The difficulty in this is if I disconnect that pipe that runs to the fuel rail, well then the electric pump is just going to push fuel backwards out of the pipe that comes from the rail. Now I could disconnect the electric pump, but then I'm not pushing any fuel to the mechanical pump. So then is it just not going to push fuel out? So what I need to do is come up with a way of being able to block the pipe in between the fuel rail and the fuel pump while allowing the discharge of the fuel pump to be open. Kind of like the way that I blocked off the injectors by just putting a bolt in, but it's a little bit harder on this fuel pipe because it's not the same thread and I don't have a bolt that I can just stick in there. But what I do have is my old pump. So if I can reposition the line that goes from the rail down to the pump so that it's just slightly in a different angle, I can attach my old pump to that line, which will block off any fuel coming backwards and allow me to see if anything comes out of this pump's discharge when the engine's turning over. So with the fuel line now kind of flipped over and I've left it loose, if I secure the old pump to the end of the line here, and then I've left that top line loose so that I can kind of pivot the location. But basically, if I can have my old pump resting here, I can tighten up these fuel connections now. And now any fuel that's being pushed to the rail by the electric pump has only two places to go. One, to the pump, which has a check valve which will stop it, or two, it's going to try and go back through the fuel pressure regulator and go back to the tank. Which is totally fine because the pump attached to the engine is still getting its fuel supplied. Now, if there's fuel going to that pump, it can shoot it out the discharge right here, which we should be able to capture on camera. Could this be it? Interesting, for a couple of reasons. Firstly, there was fuel coming out here before the pump was turning over, which means the electric pump is pushing all the way through to the outlet, which means it's pushing past the fuel delivery valve that should be closed. Now, it could be that it's not closed tight enough because there's no pump pressure up against it, or because it's not seeing any back pressure from the fuel rail to keep it closed. But still interesting. Now that said, the pump is definitely moving fuel and pulsing, so fuel is being delivered to the pumping element, and the pumping element is pumping it, and it is coming out of the pump. Now, this doesn't mean that the pump is capable of creating pressure, but at least I know it can flow all the way through. So what's next? One of the things I was a little suspicious of when I was doing the last test was that no matter what was occurring, the fuel pressure displayed was exactly the same to the third decimal place. So when I was reading fuel pressure on here, it didn't change whether the engine was running, whether the engine, I guess the engine was never running, whether the engine was cranking, or whether it was just static fuel pressure from the electric pump. That to me is a little suspicious that it didn't waver to the third decimal. So I'm going to yet again replace the pressure sensor. Only this time I'm going to replace it with a brand new sensor. And one thing I'm going to do before I put this in is just plug it in outside the fuel system and see if it reads 0. Then when I put it in the fuel system, we'll see if it reads something other than 0. If you didn't watch the video where I swapped this out before, it's located in the back of the rail. And by taking the bracket off behind the engine, that's this bracket here, you can access this with a 27mm socket straight from the back. Pop the plug off the old sensor and pop the new sensor on. Well, this is interesting. We're jumping between 29 psi and 0. Of course, it's not going to show 0. There you go. So a sensor that's outside the fuel system is reading 30 psi. That seems a little strange at first, but really if you think about it, if this system is expecting somewhere between 0 and 30,000 psi, and we're at 30, that's like 0.1% of full scale, so it may just be the accuracy of the sensor. But either way, before we put it in, I want to make sure that that 29 is capable of changing to something else, so a little bit of air should give us a proof test. Not going to be perfect, but there you go. That went up to 100 there. So it's definitely capable of reading pressure change. Still a little odd that it's reading 30 psi to 3 decimal places and isn't really capable of reading within the first 10. Everything back together in there, but because I have the ignition keyed off, we're not getting a signal from the computer. So key the ignition back on and see what we get for fuel pressure. It may take a little bit. Oh, look at that. All right, so we're still reading 29 psi there. Again, interesting because we should have about 60. There could be some air trapped in there. What we do know for sure is that the sensor that's in there does react to pressure because we proved it with air. So if we crank and the pressure doesn't change, at least we know the fuel rail pressure isn't changing. No change whatsoever. Since we proved that the pressure sensor can read about 100 psi, or at least a change from about 0 to 100 psi, my shop air is somewhere between 100 and 150 psi. If the pump was capable of creating anywhere between 100 and 150 psi, the sensor that's in there now would be registering it, or the fuel rail's dumping it back to the tank. I think we're down to 2 things. Pump not making pressure, regulator returning it. Now, if the regulator is returning it, it's time to put a brand new one in. But there's one more thing that could be going on here with the regulator. Is the computer telling the regulator to open? Well, how about we trick the computer and we'll plug this regulator in to the computer and leave the other one with no power, so it shouldn't be able to open. So computer's off right now. We're reading NA for pressure on everything. I've got this regulator plugged into the harness and this one not. This is going to tell us 2 things. 1, does this move when the computer tells it to, when I key the ignition on and off? And 2, if it can't actuate this one, it should be closed. And if it's closed, we should be able to build a higher fuel rail pressure. Let's give it a try. Rail pressure 29. I didn't watch that when I keyed it on, but let's try giving it a short crank and see if anything happens. I don't see any difference in the fuel pressure, and I didn't see the regulator open or close. Interesting again. I think this just means that we can rule out that the computer is telling the pressure regulating valve to open because it didn't open the new one. Let's swap out the regulator and see if that makes a difference. Now, since I've already done an entire video on swapping out the fuel pressure regulator and the fuel pressure sensor in the rail, I won't bore you by showing you the whole thing again. If you haven't seen it, take a look in the video description and you will find a link to that video. And so just like that, it's done. The new fuel rail pressure regulator is in, and I realized that I didn't do something last time, and that is the teach-in process for replacing this. Now, this is something that you can do with the Autel, so I'm going to show you how to do it. Once you're into the vehicle, you go into the engine control unit. Once you're into the engine control unit, we will select special function, and in here, teach-in process. And once we're into the teach-in process, we can go to the pressure limiting valve in the rail. And this will allow us to tell it there's a new piece in there. We press, the ignition is on, that's the only requirement, right? F1 to start the process. And this should learn the values of the unit that's in there. Now, not all of the components on the engine require you to go through a teach-in process, but the pressure regulating valve is one of them, and you do need a tool like the Autel scanner in order to be able to do that. So make sure you take a look at the links in the video description so you can get the right Autel scanner to work with your Fuso. Was this the missing puzzle piece and the key to helping us build fuel pressure, allowing us to start the engine? Well, make sure you tune in next week. I'm just kidding, I wouldn't do that to you. Now, if you are enjoying this content, please make sure you hit like, hit subscribe, share the video around if you think it'll help someone, throw a comment down below, and if you feel like it, scan that QR code or hit the link in the video description to help support the channel directly. It's greatly appreciated. Well, would you look at that? That was fuel pressure, and that was building. That is the first time I have seen fuel pressure build in probably 8 to 10 months. This proves that the fuel pump is capable of producing significant pressure because that went over 5,000 PSI. Now we need to get the injectors reconnected. Is this gonna be it? Make sure you tune in next week. I'm not waiting until next week to try this. We're doing it now. I'm not even gonna show you putting it back together. I mean like right now.